I'm Anil Kumar sharing with you an excellent question on probability based on counting principles. Now, this is a popular question in many test papers where calculator is allowed. And so you can also expect this in new format for SAT. The main idea of sharing this question here is to avoid calculator error when we calculate such big numbers, right? I do have videos where same question has been solved using students less than 40. So everywhere, most of the time, you will see that the number of students are less than 40. 40 is kind of critical number for such questions. You will soon realize why. So let's get into the question now. It says, there are 40 students in a class. What is the probability that at least 2 students share the same birthday? Okay. So whenever there is a probability question, we think about total options which we have. So there are 365 days and 40 students. So every student could choose from any day of the year. So it is 365 to the power of 40. So that is the total number of options. Now to say what is the probability that at least 2 students share the same birthday? So we'll say, well, we'll work out the probability for the condition that no student share birthday. Correct. So we'll do that, and then we know our answer will be probability for the answer will be at least 2 students share will be 1 minus probability of A, right? So that's the whole idea. So that is to say, we want to say that all students have unique birthdays. Nothing matches, correct? In that case, to find the total number, the first student has 365 choices. Now, once that is done, we are left with 364. Once that is done, we are left with 363 and so on. Perfect. So this is for all 40. So we'll have this for 40 students. Perfect. Which I could write in permutation form as out of 365, we are selecting 40 items. Correct? Any 40 days. That is what you get. And therefore, the probability for A, which is unique birthdays, will be 365 P40, which is n of A, divided by n of S, which is 365 to the power of 40. Now the problem here is that as soon as I do 365 to the power of 40 and calculate, I get math error, right? So I cannot really calculate this answer. So that's a huge problem. How do I do that, right? So what we are left with is to simplify this portion. So if you simplify, what you realize is that this could be written as, this number, 365 and 365, both are in the denominator. Perfect? Is that clear? So think like this. I could write this as 365 times. Now we are left with 364 P39. So I've already taken 1 here. And in the denominator, I could write this as 365 times 365 to the power of 39. Does it make sense to you? Now, this is a key step. So we cancel these 365s, and what we remain with is 364 P39 in the numerator divided by 365 to the power of 39. You get an idea. Now that number is not that large, and you can use calculator to find it. Perfect. So that is the probability of unique birthdays. So this is A is unique. birthdays. So let's find our answer. That is the probability of at least 2 common birthday, which is 1 minus all this, which is 364, probability, permutation 39, 365 to the power of 39, right? So that is what it is. So let's calculate everything in one shot. So we get 1 minus 364 P 39 divided by 365 to the power of 39 equal to. So we get a number which is 0.89123 and so on. Do you see that answer? So we are able to calculate, which is almost 89%, right? So 89%. Do you see that? It's very highly likely, perfect, almost 90% chances that in a class of 40, 2 students will have birthdays on the same day, at least, right? There could be more number of days where students may share their birthday. So I hope you understand and appreciate from where it is coming. Sometimes it becomes difficult to directly calculate values using your calculator, and these test questions could be answered if you could simplify a bit and then use calculator. So that's the whole idea. I hope that helps. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.